So section 4.4, the good news is it's not really any new formulas. We're going to be doing applications of linear systems. The bad news is, those of you who don't like word questions, the applications are going to be word questions. So let's go ahead and kind of work this out. We have Amy and Brian. So I'm going to go ahead and call one variable A, the other one B. That's kind of convenient. And it says Amy is 3 years older than Brian. We've done this kind of thing before. So Amy, A, is 3 more than or older than Brian. So it's Brian's age plus 3 more. Amy is 3 years older than Brian. That makes sense. However, if Brian were to double his age, so if we took Brian's age and we doubled it, now double does not mean square. Double means we take his age and we multiply it times 2. Okay? Does not mean B times B, it means B times 2. We took his age and doubled it and subtracted it by 5. The result, or it would equal 4 years older than Amy. So that would be Amy's age plus 4. Brian doubles his age and subtracted 5. The result would be 4 years older than Amy. How old are Amy and Brian? Okay. This, I can use any method I want. We could hypothetically graph these and find out where they meet, the A and B that they have in common, and we could solve for their age. But this to me is screaming method 2. Why is it? Well, method 2, my first step is to get a variable by itself. A equals or B equals. I've already got that. A equals B plus 3. So what does that do for me? I can go to the, so that's kind of my first step's already done. I can take that and I can substitute that into the other equation in place of A, and that would be step 2. So that 2B minus 5 would equal A, which is B plus 3 plus 4. So we substitute and we solve. 2B minus 5 is equal to B about plus 7. Get the variable by itself on one side, so that B minus 5 equals 7. So B must be about 12. Brian must be 12 years old. How old's Amy? Well, it says that she is 3 more than Brian. So step 3, Amy is Brian's age plus 3. Amy is 15. Now in the past, what we would do is we would write this as a point. That doesn't really make sense in the context of the question. So what would we say? We would say, well, Amy is 15. Brian is 12. So they're going to have you answer it by kind of filling it in like that. If you wrote it as a point, I'm not going to mark you wrong. But I could have called Amy X and Brian Y, or switched it, so the point doesn't matter as much in the word questions. Carrie and Diego are headed to the vending machine. They have decided to pool their money. Carrie has only quarters, Diego has only dimes. Together they have 10 coins. Okay, so we have Carrie and we have Diego. I'm going to call the amount of coins Carrie has, how about C? Number of coins that Carrie had, and D would be the number of coins Diego has. Okay? A couple different ways that we're going to solve this. We need to be able to set up a couple different formulas. We have total amount, and what that'll be is basically the amount of Carrie's and plus the amount of Diego's. So basically, so the number of coins for Carrie plus the number of coins for Diego. Well, we have a total amount. Together they have 10 coins. That's the total amount. So I can say 10 is their total amount. And we don't know how many coins Carrie has and how many Diego has, so we'll call it C plus D. there's our first equation. Total amount. Okay, so total amount equals the number of coins that Carrie has plus the number of coins Diego has. And we fill in the total amount. We fill in C for that unknown, D for that unknown. The second one is this dollar amount, $2.05. That's not a total amount. That's like our total. A lot of times it'll be like a total cost or total money. Okay? And what that's going to be is the number of coins that Carrie has times its cost or value. So it'll be the cost or value times the number plus the cost or value of the second one times its number plus, and we could keep going on this, but this is what we have. We have the total dollars. That's $2.05. Well, what's the cost? What's the value of Carrie's coins? Well, Carrie has quarters, so her value is 0.25 times how many coins does Carrie have? C. Plus, Diego has dimes, so that would be a value of 0.10 times D. So basically multiplying their amount times their value gives us the total they have together, $2.05. Now out of these two formulas, this is probably my least favorite one because we don't like those decimals. We can deal with that, right? If we want to move the decimal twice, we basically take the whole equation, times it by 10 twice, or 100. And what does that give us? 205 is equal to 25C plus 10D. Now this equation is not set up for substitution. It would not be difficult to take this and solve for C or solve for D and do substitution. But what I'm going to do is I'm going to take the 10 is equal to C plus D, and I'm going to choose a variable to get rid of. Generally, we look at the smaller numbers. I've got a 10D. I could make that a 10D by multiplying the the bottom equation times 10. Here's the problem. I get 100. I get 10C. I get 10D. Those will not eliminate. Don't just do that. They won't eliminate because 10 plus 10 is 20. Remember, for them to cancel, I need one to be positive and the other one must be negative. So rather than multiplying by just a 10, we should have multiplied by a negative 10, which makes the 100 negative and both the 10s negative. Now, 10 minus 10 cancels out, leaving me with 105 is equal to about 15C. Divide by the 15. I want to say 7. C is equal to 7. All done? No. Remember, we got to figure out how many coins Diego has. Well, Diego has 10 is equal to C, 7 plus D. Subtracting the 7, D must equal 3. Take a second and verify this. I know that 7 plus 3 is 10, so I know it checks out that equation, but it should also check out with the amount. So what I should be able to do is take 7 coins times 25 cents, so 7 quarters plus 3 dimes. Let's see, where's my calculator? So 7 quarters plus 3 dimes. And I think they said it should be $2.05, and it's $2.05. So verify that it checks out both equations. Diego has 3 coins, and Carrie has 7. Pharmacist needs 100 liters of 50% alcohol solution. She currently has 30% and 80% solutions. This doesn't work, right? But she can mix them. How many liters of each would be required to make 100 liters of 50%? Okay. We have a total amount. Our total amount we want is 100. We have 2 different mixtures. The 30% alcohol solution we'll call that amount X. The 80%, we'll call that amount Y. I know that, remember, we have a total amount. If I add X plus Y, that should equal a total of 100 liters. The amount of 30% plus the amount of 80%, I'm going to total 100 liters there. So that's our total amount. This next part is funny because it's really scary for a lot of people, but if you think about it like we did before we did cost times X, cost times Y, it's the same idea. We're just going to do the percent of X plus the percent of Y should equal the percent of the total. So our kind of new equation, but it's really not new, is it's going to be the percent times X plus the percent times Y equals the percent times the total. Taught. I'll scoot that over. Alright, so what do we have here? Well, what's the percentage of X? Well, that's going to be a 30% or 0.3 mixture. Plus, what's the percent of Y? 0.8 is going to equal, well, at the end, what's the total mixture? Well, 50% times 100. There's a way of visualizing this, and I want to take a second and do that. Think of it this way. I know that I'm going to add kind of a barrel or an amount of X, plus I'm going to add a barrel or amount of Y, and that should equal 100 liters, right? What I do when I multiply the percent is I go, well, what? 30% of X is the mixture. So that's the 0.3X plus 80% of the Y. And at the end, when I add these two, I want it to level out to what? 50% of the 100. So we're taking the total amounts, we're multiplying them by the percents, and then we should end up with kind of this equation. Okay. Once again, not 11 the decimals. So I'm going to multiply, let's go ahead and clean this up anyway. So, oops, too far. So I'm looking at 0.3x plus 0.8y is equal to half of 100, should be 50. We don't like this, so we're going to multiply it by 10. Get 3x plus 8y equals 500. The second equation we had was x plus y equals 100. Now I could solve for x or y and plug it in. There's nothing wrong with that. You could say x is equal to 100 minus y, or y is equal to 100 minus x, and substitute it. But I'm going to just say, for me on this one, since it's already lined up x and y, I'm just going to make one of the variables eliminate. The smaller of them this time would be the x. So I'm going to take that bottom equation and I want to turn that x into a, not just a 3x, right? Not just times 3, times it by a negative 3. So that I get a negative 3x, a negative 3y, and a negative 300. It distributes to all of them. Now the x's cancel. We're left with 5y equals 200. Dividing, y is equal to 40. Is that our final answer? No, remember we had two mixtures, right? If y is 40, we knew that x plus y made 100, right? What plus 40 is 100? X must be, how about 60? Now I know that those two total to 100. I would encourage you to check out the mixture. If I'm using 60 liters of X and 30% of it is alcohol, what is 30% of 60 plus 80% of 40? Let's see. Is it 30% of 60 plus 80% of 40? And what should we end up with? Well, 50% of 100, or 50 liters of alcohol. Okay? So this is a way of mixing. I don't know that you're going to do this, but one easy application for this is a pool, right? I'm checking the pool. The chemicals aren't right. I know what it should be. I know how much there is. How much should I add? This is that same equation. Like, I'm not going to be a pool guy. Okay, well, maybe you're going to own a pool someday and want to balance it. That's fine. Maybe you want to mix beverages, alcoholic beverages, and you want to mix chemicals and mix, there are a lot of applications for this. I can't tell you exactly how you're going to use it. My job is just to show you a couple applications of our systems. I think this is our last one. So if a plane flies 560 miles in 1.75 hours traveling with the wind, and the return trip against the same wind takes the plane 2 hours, find the speed of the plane and the speed of the wind. Okay. This is a dirt question. We have distance, rate, and time. And I love the way this book handles this. They set this up into a really nice diagram. And we go, okay, we know we went 560 miles. And it took us 1.7 hours. But that was with the wind. And so really we're going to have kind of two parts to this. So you're going to have it with the wind. And then you're going to have it against the wind. Well, against the wind, if we were flying back, right, how far did they travel? Well, the same distance, right? So the same 560. Coming back, it takes 2 hours. And what is the rate? We don't know the rate of the plane or the wind, right? So I'm going to call P the rate of the plane. And I'm going to call W the rate of the wind. If I'm going with the wind, then what I'm doing is I'm going to add these rates. I'm going to be going faster with the wind. If I'm going against the wind, I'm going to have the speed of the plane, but I'm going to take away the force of the wind. It's basically going to make me slower. Okay? And then the last thing we need to be able to do is relate these three things. Our function for this is D equals R times T. Distance equals rate times time. So we end up with the following equations. The first one, 560 equals P plus W times 1.75. On the bottom, we get 560 equals P minus W times 2. Before I do anything with these equations, I'm going to go ahead and take that number and I'm going to distribute it. So simplifying this one, I get 560 equals 1.75P plus 1.75W. On the bottom, I get 560 is equal to 2P, 2W. Now, I'm not liking this decimal, so I'm going to take this top equation, and I'm going to multiply it times 100 to move the decimal twice. That's going to make that first number really big and scary. Okay, 560 times 100 would be 5, 6, and 2 zeros is equal to 175P plus 175W. Oh, this is crummy. I'm looking at this, and I've got a 2. And that 2 is not going to turn into a 175, is it? So what do we need to do? Well, I see that all three of these numbers, 560, 2, and 2, are all even. So I'm going to take this equation, and I'm going to divide it all by the 2. And get 280 is equal to just P plus W. Alright, so real quick, what I noticed here is that when I distributed the 2, that should have been 2P minus 2W. So this becomes P minus W. So I don't know what I was thinking there. But now when I multiply everything by 175, 280 times 175, I'm not doing it in my head, about 280 times 175, 49,000 is equal to positive 175p minus 175w. Now these are set up. The w's cancel out. We get 350p is equal to, let me make sure those add to 54,600. Oh lordy lordy, I hope. Does 350 go in there? So 54,600. 54,600 divided by 350. 156. That is the speed of the plane. So how fast is the wind going? Well, I'm going to go ahead and plug it into that second equation, even though it's got a negative W, because I do not like having these decimals. So I'm going to say 280 is equal to P 156 minus the W. I subtract 156. How about 124? Negative? No, positive. Is equal to negative W. So the wind must be blowing 124, negative 124. So 124 miles against.